coming up for you now. This is Gareth. Hopefully everybody recognizes Gareth from the keynote this morning, talking about Docker Desktop and what Docker is doing for developers. He's got a great session for you here, so we can see a little bit more detail about what he showed in the keynote this morning, and some more details on what's happening with Docker Desktop and what we're doing with developers. He's also got some really exciting things that didn't fit into the keynote this morning that his group and his product team has been working on. So it should be a fantastic session. We'll have time for some Q&A at the end as well, so I'll run around with the microphone and let everybody ask questions. But please welcome Gareth.
Okay, so yeah, as Jim kindly said, I'm Gareth Rushgrove. I'm one of the product managers at Docker, based out of the UK. So I'm going to talk sort of this afternoon on using Docker locally. I'm basically just focusing in on the developer use case, and I'll talk about what I mean by developers in a moment. But I'm going to talk about Docker Desktop. I'm going to talk about the sort of the journey that has happened with sort of building Docker images, both what's there, what's happened, where are we going. And I'm going to do the same for sort of describing applications as well. The sort of thread for this talk is really around I want to set some context, but also a bit of direction of travel stuff, and I'll throw some demos in the middle. I'm also going to talk a little bit about IDEs and editors. Obviously, for those that were in the keynote, I spent a bunch of time talking about graphical user interfaces. The command line is definitely synonymous with the Docker experience today, but there's also this interesting bit in the middle around IDEs. And then I'm going to cover a bunch of the stuff that was in the keynote, and then a bit more around some of the new graphical tools we're working on. So hopefully a sort of smorgasbord of stuff. But first, just a little bit of I'm Docker for developers. What do we mean by developers? And I think from my point of view, and I think certainly in the context of this talk, in the context of Docker, it's not just the sort of that professional software developer or the enterprise dev writing a lot of Java. It really is a huge, wide range of people writing software in various different forms. And that might be including those sort of professional, sort of hardcore developer, but it could also be the hobbyist or the student or the systems administrator or the operators or increasingly people like data scientists and researchers who are writing a bit of code or needing to run custom applications. It really is a very wide group of people that we feel that Docker is relevant to. So I might use the word developer, but don't think I'm against systems administrators or data scientists. Really, I'm talking about the same bunch of people. So, kicking off with a bit about where Docker Desktop fits in. I'll sort of fill in the rest of these blanks as we go through this talk. But if you Docker sort of starts with the engine. That's the thing that powers all of the sort of the things that you want to do on top. That's where you run the containers. Docker Desktop basically provides that in a way that's packaged up for you to run on your local machine. And Docker's main use case is running server-based applications. But as a developer, and I'd sort of broad church, being able to run locally allows you to be really fast when you're building things. You're not having to wait. You're not having to rely on third-party sort of infrastructure. You're not having to rely on a network connection to some computer somewhere. I spent a lot of time either flying or on trains for some reason. And being able to do things locally has always been part of my personal workflow. By bringing Docker to the desktop, by you installing it locally, it really aims to sort of solve I think 3 key problems. One is just the classic works on my machine. Another is around that sort of point of productivity. Sometimes just having something locally allows for a much faster feedback cycle than relying on something on the other side of a CI system. You still want those systems, and they'll still catch issues. If you can catch more issues locally, you'll be more productive. And I think another area as well that you see time and time again is project onboarding. where people take, and often Docker on their local machine and a compose file, and that's it. That's all you need. You can, someone joins, new developer, and I'm sure some of you have got horror stories. I've certainly got certainly a few of like project onboarding being weeks. Like someone comes in and installing things on their machine in such a way that it means that they can run and compile the application that they're meant to be working on, that you're paying for them to work on, is a painful exercise. And it's inconsistent between different developers and development machines. Like the combination of just desktop and compose often fixes that for a great many organizations. Where Docker Desktop sort of like starts to get really valuable is in really sort of, it's optimized for developers. Like Docker, and ultimately it is just bringing you Docker, but it's not just Docker. It's a local experience of Docker. All the APIs are the same. It's still the same code running the engine and the containers. But actually, we provide obviously a super lightweight virtual machine that just stays out of your way. It's not like you're managing a virtual machine. Yes, it's like a VM. Yes, it's running on a hypervisor. But the work we've done basically just abstracts you away from all the faff of running that. I'm sure lots of people have sort of previously used like desktop virtualization to solve sort of similar problems. And you end up with a management overhead. You end up with, now everyone is basically a sysadmin on their local machine. Docker Desktop doesn't have that problem. We also do a lot of work around just file system optimization and really sort of improving the performance for like local developer like workflows. Like yes, there's a VM, but like given that it's used for specific things, we can do a lot of like low-level performance and also native networking support. So one of the really nice things with desktop, sort of compared to other tools, is often like, well, you just use localhost. There's no other IP that you need to remember. There's not the sort of same sort of port mapping sort of thing. Like it's just your local network. So more recently, and so desktop's been around a few years, and originally on Mac and then on Windows, and sort of just releasing sort of both sort of stability fixes, improvements, more UI bits and pieces, and like with newer versions of Docker for a little while. More recently, we added Kubernetes support within the Edge version of Docker Desktop. So if you're running Edge at the moment, you can go into the settings and you just click Enable Kubernetes. Like after that downloads and starts up, not only do you have Docker running, you have a local Kubernetes cluster. It's by far and away the easiest way as a developer with a local machine to try out Kubernetes. And if you're developing against Kubernetes, all the same benefits apply. You have a local Kubernetes install, you have the API there, and it's also the sort of big badge at the side. It's certified Kubernetes. This is not us sort of doing anything weird. Like this is the upstream Kubernetes version. Like Docker Desktop is certified. Actually, previous version was certified with 1.9, but we've just shipped with 1.10. I think yesterday we got the certification badge for that as well. So like, if things are running there, they're going to run on other certified Kubernetes distributions like Docker EE. So desktop exists, like it's by far and away the sort of easiest way of, like if you're building cloud native applications, if you're building container-based applications, if you're using Kubernetes, like Docker for Desktop is sort of just like, if you haven't already installed it, just go install it and it will make your life easier. Whatever sort of type of development work you're doing, it's just a really good start, stays out of your way and provides like access to all those APIs. But once you have them, what do you want to do? Because it's not, you don't really just want to run it because it's cool. The first thing really I think that most people sort of like get into Docker, like sort of you're trying out Docker is, well, you'll build an image. And obviously, again, let's fill out some boxes. And this is where like the Dockerfile comes in. And obviously, using Dockerfile to build Docker images, and it's having like really good command line tools to sort of assist with that. And this is really sort of like the foundation of Docker. These were parts and parcel of like Docker at that very first like open source release. So I'm sure like after that, certainly a bunch of years and sort of the audience we have in the room, like most people or lots of people will be familiar with the Dockerfile. And this has been like wildly successful. I mean, there are like millions of Dockerfiles on GitHub for like just basically any type of software you can imagine. Plus, lots of people will have a whole library of private ones. It's just a simple way of like building a container image, describing the commands, describing the sort of the properties of that software image. Dockerfile provides, I think, the sort of like why Dockerfile versus other things, and like it provides a simple textual format, and like that can be included in your source code repositories however you choose. Like some people might create a sort of a library repository with a load of Dockerfiles. Others might include a Dockerfile with the application itself. Like Dockerfile itself and the Docker build tools are not opinionated about that. Like you get to bring those opinions. It's also just, whether you're writing in like Ruby or Java or .NET, whether you're targeting Windows or Linux, whether you're targeting both, like historically, and when it comes to sort of the libraries that you're using, they've always had their own package managers. You then throw in the sort of systems package managers for like different Linux distributions. Obviously, different Linux distributions have different package managers. The explosion of complexity around that, if you're working in an environment where you're using multiple languages and frameworks, is just a massive burden that ultimately Docker as a single one way of packaging up an application solves very nicely. And I think one of the reasons for, I guess, the success of Dockerfile is really just that it's familiar already. And when you look at the sort of run commands, well, if you're a Python developer, well, they were the commands you were running to install your application. It's not introducing any syntax or bringing in anything else like overly new. The actual meat of the work is something you're already familiar with, which makes getting started really easy. And Dockerfile ultimately is then used by like Docker build. So in your directory, run Docker build. I in this case, sort of tag it with a friendly hello, and it builds an image. We have an image. We've got this split. We've got the Docker file that describes what you want. You basically sort of compile that into the Docker image, which is then the thing you can share and distribute and reuse. And obviously, thanks to you and like a whole like world of people at this point, you shared the numbers for Hub and the number of images on there and the number of downloads that are billions a year. It's super popular. Dockerfile isn't without sort of, I guess, limitations. It's a really good solution for a certain set of problems. And obviously as well, it started out fairly simple. What that did lead to was a sort of explosion of things like this. And ultimately, things like the builder pattern and writing shell scripts to wrap Dockerfile because you wanted to copy things between. Everyone wanted smaller images. And this really leads to sort of, Dockerfile is this simple textual format. This is not a simple textual format. This is sort of hard to maintain shell scripting craziness. The good news there, and I think lots of you will have already sort of been using this, but those that haven't, I wanted to really call it out because it's super powerful, is writing that sort of wrapping is generally speaking no longer required due to the work that went into multi-stage builds. So in terms of just building Docker images and Dockerfile, they were part of Docker to start with. Multi-stage builds is much newer. And in this case, you're able to replace actually several Docker files and a somewhat crazy shell script with a Docker file. This is able to build multiple images from one file, and certainly for languages that are sort of compiled and have a sort of static binary, Go being a good example, being able to do this is very simple. Again, the first image we'll build, it will compile the application, and then we'll copy just the static binary into the second one. That means we don't need our build tool chain or any sort of testing tools in our final production image. That's going to make it much smaller and also more secure just from less surface area. So if you haven't already sort of seen multi-stage builds, like, I would definitely get using them. There's actually a load of power behind multi-stage builds. They're sort of deceptively simple. I think a lot like a lot of the other sort of Docker tooling, but actually quite deep if you choose to like use some of the power features. Handily Tonis, who's one of the developers who works on Docker Engine and Buildkit and a bunch of the other sort of build tooling, just published this handily just before DockerCon. So definitely check this out. It's sort of all sorts of advanced multi-stage build patterns. So definitely worth a read. I mentioned something in passing there, and I wanted to, again, like on this sort of journey from where Docker started with build to where we are now. Something that's cropped up a few times is Buildkit. So I guess what we've been doing in a number of cases is taking Docker as it was, and we've been extracting out parts of it so they can be reused at a lower level, and then reintegrating them back into Docker. The best example of this so far has been Containerd. Containerd is the core runtime, the container runtime. And that was extracted out of Docker, standardized, is usable standalone, but it's probably more interestingly then integrated back into Docker, and which provides that high-level user interface. Buildkit is that for the build portion. So we've sort of reimagined and built a low-level component for the build stuff, and that's actually, this was merged yesterday or the day before, I think, so this is no longer open into master. And so Buildkit is going to provide all sorts of interesting stuff into Docker build like real soon now. So next, some of it is actually just faster builds. I saw some benchmarking, and Docker build is already sort of like pretty much like on par or faster than like other tools people might be using. Buildkit sort of blows them all out of the water. It's super fast, mainly by being very smart about being able to parallelize and cache things. Like everything that we've learned from everyone building Docker images, we've been able to say, look, these are the optimizations we need to make that even faster. It also has a number of tricks around sort of actually being able to take that cache as a first-class citizen, potentially, and then make it remote. So you could potentially share build caches either across a build farm or amongst a team of developers. Again, like ultimately resulting again in faster builds where you need them. Speed and performance and like just sort of actually a nicer output are sort of some of the bits and pieces. I'm mainly interested in the last two. Dockerfile has a specific syntax. And sometimes you're like, oh, I wish it had this one command. The reality is actually, because Dockerfile supports everyone, it might just be you and a few people who want that. Adding that to Dockerfile results in Dockerfile getting huge and basically out of hand. Buildkit will allow for you to extend the Dockerfile syntax yourself, basically with a plugin model. You can ultimately write little macros for Dockerfile. I think this is super powerful. I played with a prototype around this a few years ago at a DockerCon, and like now there's actually a real way of doing this. I'm sort of super stoked to see what people do. There's also the potential for building entire new front ends that might not be built on Dockerfile, but that work with all the same underlying infrastructure and are compatible with the resulting images. I think there's a load of areas of sort of innovation that can happen there. Like Dockerfile is this sort of perfect solution for the majority of problems. But on the edges, there's a load of areas to sort of experiment with, I think. So, I'll grab a quick drink of water. So, once we've got images, well, you can run those individual images. But that's maybe not that interesting. Because the reality is most applications consist of multiple services. And that might be because it's a sort of complex microservice-based application you're writing, or it might just be that you have a monolith and a database. Either way, there's some dependency to bringing back up. Most things, it's not normally enough to just run a single service, apart from the sort of simplest use cases. And this is where Docker Compose comes in, and the Compose file. Similar to Dockerfile, but obviously solving a different problem. Compose files are all about describing a set of interrelated services, often along with like basically the networks that are required to connect them together, volumes for storage, and secrets that sort of allow you to access other services. It's all based on sort of YAML format and comes with tools to just run those applications. And Docker Compose Up is able to just simply start all of those services in the right order, bring everything up together, and again, in one command. You can just share that compose file in your project. Someone who doesn't know how all of that works, just Docker Compose Up, and you have it all running. Again, back to that sort of strength for, like, project onboarding is sort of a killer use case. But this also works well to deploy applications into production. And compose files echo like some of the strengths of Dockerfile in that, again, it's a fairly straightforward textual format that you can include alongside your source control system. Like, it doesn't need special sort of versioning support. Like, you're already versioning it with your code. And as mentioned, like, most applications do consist of multiple services. You can use Compose to wrap just a single service application. It's obviously much more interesting the more complex application you have. And having one tool that sort of scales with that, I think, is powerful as well. So Compose, again, has been around for a good while at this point, and certainly several years, sort of 3-4 years. But more recently, we've done work to support using Compose on Kubernetes. So I'm using Docker Stack, which is basically another interface to Compose that works with Docker. You can just take the same Compose files that you're deploying either locally or onto Swarm and deploy them on Kubernetes. This works with Docker Desktop and with Docker Enterprise Edition. So if you haven't seen that, it's definitely worth having a look. And the Kubernetes API is very powerful, but also quite verbose. If you've written sort of service files and deployment files and pod files and the rest of it, it's a large API with sort of quite verbose configuration. Realistically, that's the wire format. It's the assembly language for Kubernetes. What Compose does is gives you a higher level abstraction. And it's not, like, this has been done, I think some people were sort of confused about how this was working, but Kubernetes is designed to be extended. It's designed to be extended within actually a large number of different places. And then there's a couple of talks tomorrow about Kubernetes extensions. But API servers and CRDs are a big part of it, where you're adding new objects to Kubernetes. And actually, all we do is add the stack. So with Compose files, the model, if you like, underneath is stacks. You can use all the Kubernetes native commands to talk about Docker stacks within the with the Kubernetes and Compose support. Like, this gives you a higher level description. It's just much more succinct. Specifically, it's optimized for basically one use case. It just happens to be probably by far and away the most common use case for most people, which is just interconnected IP services. And like, you'll end up with less code, frankly, and it's also portable between Swarm, Kubernetes, or just a Docker engine. I think they're all sort of useful properties for like an application description language. It's worth noting something with these boxes, though, and obviously I drew the boxes to call this out explicitly. But there are benefits that we talked about of having a Docker file that results in a Docker image. The image is super shareable, and there are lots of them shared on Hub. Docker files are the build instructions. Well, it turns out Compose files are very, they're analogous to Docker files in this context. But sharing is actually really difficult because there isn't something in that box. And I think this leads to some areas that we can improve with Compose that I'll talk about in a second. And some of it is just that it's slightly more difficult to reuse Compose files in the same way as with Dockerfile. Dockerfile is reusable mainly by copy and paste. Compose is similar. Docker images are ultra shareable and reusable. There's also no clear interface for different types of concerns in the typical Compose model. And you can wrap your own tooling around this, but if you want different things in different environments, there's not a clear interface for that. And there's no central place to share. And like Docker Hub is a fantastic resource for Docker images. What about compose files? So we've been experimenting with something that we're calling application packages at the moment. And this is really taking the compose file and adding a few small bits to it, mainly around metadata and explicit settings, aimed really to address all of those problems I just talked about. So I think Jim mentioned like there obviously we couldn't fit everything into the keynote this morning. So one of the things I'm announcing now is that we're open sourcing a Docker app. So this is the picture does have a lock on it, but this is open source now as of like 20 minutes ago or something, and available to play with. And this is aimed at solving those exact problems. I will do a quick demo of that now. All being well, I haven't got a fortune cookie, so this might go horribly wrong, apart from the fact I used one this morning. So I didn't think about that. I have a compose file. So this is just a compose file. There's nothing special about it. Obviously, I've picked something that's trivially simple for the purposes of this example, but this would work equally well, if not actually a lot better, with a real-world sort of larger one. The only thing I will note about this compose file is obviously there is a single service. There are a few variables. Now these are something that compose spots already, but we have the version of the image there. We have the sort of the text that this would display. It's a little web server that will just echo back things to you. And we also have the port on which we'll expose this down as a variable. I'll come back to why that's interesting in a moment. But that's just a compose file. So Docker app is available as a standalone separate binary at the moment, a separate command line tool for Linux, Mac, or Windows. The reason why this is separate to the other tools at the moment is we just want to basically, it's an experiment that we want to iterate on really quickly. By having it as a standalone something, we can, it's sort of version 0.2.0, we can react really quickly to feedback. Other people can get involved. We can work on this quickly outside the stability required, for the Docker, sort of Docker CLI. I think the direction of travel here, the ideal will be, if people really like this, once this is straight up stable, this the hyphen goes away, and we get this into the Docker CLI, so you have Docker app. So don't worry too much about it being standalone. It's really just about it being experimental. So Docker app has a number of different commands, and I'll run through a sort of typical workflow. So I say we've got that compose application. I'm going to create an application. I'm going to call it hello. I'll gloss over the single file bit, but there are just different formats for the packages that we create. So I ran init, and it's generated a hello.docker app file for me based on that compose file. So let's go have a look at that. So we have a bunch of metadata. We've sort of pre-populated a default value. We've taken the name of the application. Let's fill some of this out. A demo app. So this is just metadata for the application that we're creating. We also have in there the compose file that we were using. And we also have, if you look, some settings. Now these settings were extracted out of those variables in the compose file. So I'll set some default values for these. Okay, so it's just a text file. We've got some metadata, we've got some settings, we've got the compose file. But what can we do with that? Well, first up, it's useful to actually just render the compose file. So all we've done there is we've taken, if you like, the template of the compose file and the default settings, and we've put them together. So you can see here, well, it's now published on the port we set as the default. It's the latest image. The text is here as well. Lots of people have built templating systems around compose. What we're trying to do here is provide an out-of-the-box solution to that problem. Obviously, by rendering the compose file, you could then pipe that into any other tool that wanted to use Compose. Or you could save that Compose file in disk if you had a sort of CI system based on like Git. More interesting, though, I can override parts of it. So at runtime, maybe I want a different port. So here the port's changed. We have an explicit way of overriding like parts that I defined up front. What else can we do? So I now have this Compose file. I now have this sort of interface we've created. Let's save it. So saved application as image, hello.docker app. Well, as image, well, is that just a Docker image? Let's go find out. Yes, that is just a Docker image. If you check, there's some labels here that would allow us to filter on and actually get, like we've put some of the metadata in there. But yeah, this is just a Docker image. This is where it gets more interesting. So right now, that's a text file. As the developer of that application, well, you're going to be creating that. You can version that. You can put that in your source control. And you can use that to render or deploy the application. But let's pretend instead of the developer who's creating it, we're now the operator on the other side of this, or someone who actually just wants to reuse the application you created. Well, it's a Docker image. So here, I've now moved to another directory. That directory is basically empty bar file that's nothing to do with at least this part of the demo. Well, I can run hello.docker. That's using the image that we saved. Obviously, here I have it locally. If I didn't, it would pull that image from Docker Hub. When you save, you can set a namespace. So if I wanted to store it as like Gareth R dash, like my fancy application, it will just work. In the same way as if you do Docker run, well, Docker run will do Docker pull first if you don't already have it. Rendering the Compose file is one thing. Well, what about deploy? So, to specify the application. So for those familiar with the Docker stack commands, well, this is doing that. But it's the two new things are happening. One is it's doing so from a Docker image. The other is it's rendering that Compose file and the settings file together. So that deployed the application. Just for timing, we could have also done Docker app, deploy, -- set, and change something there. But you might not want to provide all of that information at runtime. You might want to store some of those settings, those per environment settings in source control. So rather than doing the command line sort of -- set flags, well, you could provide a settings file just with alternative settings. Again, it's not all the settings. We're going to take the defaults and then we're going to override them. And I'll do render rather than deploy, but we would just point it at a settings file. And you can see here we've changed to sort of hello production. We've changed the specific version. This means there's an explicit way of sharing config separate from the description. That means rather than having to copy and paste that Compose file and sort of mutate it, you can just override specific things. And another nice touch is the ability to detect what you can override. The point here is, well, you don't need to know about what's in that Compose file because there's an explicit interface that's been built. So we have Docker app inspect. Which just presents a nice sort of friendly, informational screen about the image, about that application. We've got the name, we've got the version, we know who maintains it, we've got a description. Probably most interestingly, we've got those settings and their default values. That means, yeah, they're the things where that's set will override. They're the things that I can put into my settings file. I don't need to care how you implemented it as the operator. We've got a separation of concerns. There's a few other things that I don't have time to run through, and there's sort of a lot more ideas as well in the repository. Probably the most interesting one is Docker app Helm. Helm is basically a package manager for Kubernetes. It has all sorts of useful lifecycle hooks, and you might be standardizing on that. With this, you can use Compose to describe your application and use Helm to deploy your application on Kubernetes in IDE or desktop. So there's all sorts of other bits and pieces that we have planned, but I'll come back here. See how long I've got. So I have these slides in case the demo failed, but nothing failed, so we're all good. But they'll be handy if people are coming later. So currently, this is experimental, and check it out. Let us know what you think. It's open source, so if you want to contribute too, that would be fantastic. It's a nice small project as well, so it's a lower barrier to entry than some of the bigger ones we might have around. So I'll go fairly quickly around this because I want to get the last bit. We mentioned earlier in the keynote around just lots of people use different editors. But several of the really popular editors are actually full-fledged IDEs. There are a wide range of developers for whom they don't live in the command line, they don't live anywhere other than within Visual Studio or IntelliJ or Eclipse. And a lot of this is sort of basically third-party integration, but it's really interesting to note, some of it's super powerful. And syntax highlighting is sort of in most editors somewhere. But actually, contextual help and sort of IntelliSense type attributes are really a boon for anyone just learning Dockerfile or Compose file. And often you can actually just run your Compose-based applications and run containers directly from within your IDE. And several of them make the integration with Docker Desktop just seamless. If you have that installed, then everything just works magically. We'll talk a lot, I think we'll do a lot more about IDEs. I wanted to sort of call them out as, if you're using an IDE, check out the current integrations. But yeah, I think there's a load more ideas we have there to work with various IDE folks. But yeah, I also wanted to talk about that last bit. We want really good CLI tools. It's not an or, it's an and. Because we want really good GUI tools as well. You should be able to work with developers who don't have the same sensibilities as you, with the same tools, and it feels native to both of you, or all of you. So we announced today the work in Docker Desktop to create applications. I don't, unfortunately, have enough time to fully demo this, but if you didn't see the keynote and didn't see the sketch with Lily and Mason, I would check out the videos and live stream. But this is really all about a visual tool to do what you might do already with Compose. You can pick a series of services to build up your application. You can configure those services. So that might be as simple as overriding ports, or it might be something a lot more specific, like in this case with the Go Micro service, saying, well, this is the package name for the work I'm doing. And you can run all of your application just within the context of that GUI app, without having to sort of jump out and be a part of the command line at all. There's a lot of work we want to do here, and I have sort of planned for next. A lot of it around sort of sharing templates and services within your team. We'll provide a good set of out-of-the-box content, but we want to allow you to create your own, and also to sort of restrict potentially your colleagues from what they can use. And integration with CI systems as well is a sort of common pattern. If anyone's rolled out sort of Docker in production, you've probably done that sort of glue work with your CI system of choice yourself. We want to do more work to make that easier to just roll out of the box. And there's a bunch of more features as well we're going to work on. And calling back to the keynote, if you are interested in this, we're going to be running a sort of private beta, so just head over to beta.docker.com. Wrapping up and getting to the end. I'd love to know what people think is sort of missing from this, like sort of mental model, if you like, and other areas which we can, as Docker, sort of focus our efforts on basically just making the best possible developer experience. I think ultimately all of these areas exist today, right now. We want to make all of them better over time, and I think that's what we've been doing with like some of the examples I've shown. Like it's all about like developers, like and for Docker, and in particular for myself. We want Docker Desktop there as a fast and stable platform for you just to build applications on top of. And it's not just about Docker as like those Docker images. It's about entire applications comprised of multiple services. And it is for developers, irrespective of the user interface you're using. Like we're 5 years into the sort of Docker journey, and there's an awful lot of developers out there that don't get the chance to sort of be part of the community like as it's formed, like that can still benefit and use Docker next. So if you've enjoyed this and are interested, then and if you're not already, download Docker Desktop. It will make your life as a developer more everything, really. Try out Docker app. It's open source on GitHub. Looking for sort of just feedback, any ideas, what do you like, what do you not like. And join us on the Docker community Slack as well, where we're always sort of hanging around and talking about developer problems. OK, thanks for listening. And I don't think I've got time for questions, unfortunately. But